For centuries, discovering new materials was a slow, painstaking process. Scientists would mix chemicals, test them, and hope for the best. It could take years, even decades, to find a single useful material. But that world is ending. Artificial intelligence is now discovering new materials at a rate that would have seemed impossible just a few years ago. And it's completely transforming the way we build everything from batteries to computers. Here are 5 insane ways AI is discovering new materials in 2026. Number 1. Google DeepMind's GNoME. In 2023, DeepMind launched GNoME graph networks for materials exploration. This AI tool discovered 2.2 million new crystals. That's equivalent to 800 years' worth of human discovery. But the real breakthrough? 380,000 of those are stable materials that could actually be synthesized in a lab. Think about that. Before GNoME, humans had discovered around 20,000 stable materials total across all of history. GNoME multiplied that by a factor of 20. 736 of these predictions have already been independently created in labs around the world. GNoME uses a graph neural network that represents materials as networks of atoms, learning which atomic arrangements are stable. It combines 2 pipelines, one that creates candidates similar to known crystals, and one that explores completely new chemical combinations. Each prediction is validated through density functional theory calculations, and results are fed back to improve the model. It's a flywheel of discovery. Number 2. Microsoft's MatterGen. If GNoME predicts which materials are stable, MatterGen actually designs new ones from scratch. MatterGen is a generative AI model, think of it like DALL-E, but for crystal structures instead of images. You tell it what properties you want: high strength, specific conductivity, or the ability to conduct lithium ions, and it generates entirely new materials that match those requirements. In one test, MatterGen generated over 500,000 stable candidates and narrowed them down to 18 promising battery materials in just 80 hours. A human team doing the same work would have taken months or years. Microsoft used MatterGen to design a new battery electrolyte, which their Azure Quantum team then validated. The model was published in Nature in 2025 and has already been cited over 700 times. This is generative AI moving from art and text into the physical world. Number 3. Berkeley Lab's A-Lab. The A-Lab is the world's first fully autonomous materials synthesis laboratory. Robots guided by artificial intelligence don't just design new materials, they actually make them. Here's how it works: AI models like GNoME predict a promising new material. The A-Lab's robotic system then synthesizes it, analyzes the results with X-ray diffraction, and feeds the data back into the AI to improve future predictions. There are no humans in the loop. The A-Lab has already synthesized over 41 new materials from GNoME predictions. One of its successes is a material called Li4NG-Gu2S7, a first-of-its-kind optical material with diamond-like properties. The Materials Project, which powers much of this work, now serves over 300 million data requests per year and has over 650,000 registered users. The lab itself runs 24/7 without coffee breaks. Number 4. AI and solid-state batteries. Solid-state batteries are the holy grail of energy storage, safer and more energy-dense than lithium-ion. But finding solid materials that allow ions to move quickly has been incredibly difficult. In March 2026, researchers published a breakthrough: a machine learning pipeline that predicts Raman spectra and identifies a distinctive low-frequency signal that indicates liquid-like ion motion inside solid crystals. When ions flow through a crystal in a fluid way, they temporarily break the crystal's symmetry, producing a unique spectroscopic signature. The AI can spot this signal instantly, identifying candidate materials for solid-state electrolytes in minutes instead of months. The model was tested on a sodium-ion conductor called Na3-SBS4 and successfully detected the fast ion transport signal. This technique could dramatically accelerate the development of the next generation of batteries for electric vehicles and grid storage. And number 5, AI in the search for room-temperature superconductors. Superconductors are materials that conduct electricity with zero resistance. A room-temperature superconductor would revolutionize everything: power grids that never lose energy, maglev trains, quantum computers that actually work. But discovering them has been one of the hardest challenges in physics. In 2026, AI is changing that. Researchers are using a technique called causal discovery. AI analyzes experimental measurement data from angle-resolved photoemission spectroscopy to identify which electronic structures are actually responsible for superconductivity. German researchers used AI to discover a completely new superconducting material that humans had overlooked for decades. And just this month, a new AI tool can now identify complex quantum phases in materials in minutes, a process that used to take specialized experts weeks. We may be closer to room temperature superconductors than ever before, and AI is doing the heavy lifting. The pace of materials discovery has accelerated from decades to days. AI isn't just helping scientists in the lab, it's suggesting materials that humans never would have thought to try. From batteries that charge in minutes to superconductors that could rewire our entire electrical grid, the materials of tomorrow are being discovered today by algorithms. And the really crazy part? We're just getting started. If you enjoyed this video, smash the like button and subscribe for more incredible AI breakthroughs. Thanks for watching, and I'll see you in the next one.